Hello, students. Let's say we want the sum of all the odd numbers from 1 to 99. So one or two digit odd numbers. So let's say that's what we want. Okay. How can we get that? Well, what I could do is I could say I want the sum of this set. So give me all of the numbers from 1 to 99. And what I'm going to do is I'm going to toss out all the evens. So how am I going to do that? Well, I'm going to divide by 2 and see if it has a remainder. And those are the ones I'm going to keep, right? If it has a non-zero remainder, it must be odd. Otherwise, if the remainder was 0 when I divided by 2, that would mean it was even. Okay, let's try this. And I get the number 2,500. Now, there's other ways that I can get this, too. Another thing that I could do is I could say I want the sum. Well, I know that odds are numbers of the form 2x plus 1. So when x is 0, I'm going to get 1 here. I want this to go all the way up to 99. So when would this be 99? Well, if I take 48 and 48, that's going to give me, if I take 49 and 49, that's going to give me what when I add it together? Well, that's like 50 plus 50 minus 2. So that would be 98. So 98 plus 1 is 99. So this is correct. So if I go all the way up to 49, which means I cap this at 50, I should get the right answer. And you'll see I get the same exact thing right here. So both of these are 2,500. So this way is one way of doing it with a filter. This way is one way of doing it without a filter. Okay, let's look at some other examples with filters. Let's say we wanted, I don't know, the sum of the 3-digit palindromes. So what's a palindrome? Well, it's something that reads the same left or right, like 585 is a palindrome, or 5665 is a palindrome. But 5656 is not a palindrome because this reads different from left to right and right to left. If I went right to left, I'd get 6565. If I go left to right, I get 5656. Okay, so I want the sum of the 3-digit palindromes. Okay, so if I have a 3-digit palindrome, all that means is the first digit and the last digit are the same. So how could I get the first digit of a number? Well, what I could do, like let's say I have 456, I could divide by 100 and round down. And here this would give me the first digit, which would be 4. And this will work for any 3-digit number I want. Okay, how can I get the last number? Well, if I divide by 10, the last number would be the remainder, right? Because 10 would go into 450 evenly, and it would have 6 left over. So if I take, say, 456, and I take the remainder when I divide by 10, sorry, that was foreshadowing about the answer there that I typed. But yes, I get 6, which is going to be the rightmost digit. So I know I have the leftmost digit. I know I have the rightmost digit. So what I really want here is the sum of all the 3-digit numbers, x for x in the range. So I want to go starting at 100 and up to 999. But I only want to include it if the left digit is the same as the right digit. So that would mean x, when I integer divide by 100, that's the same as x when I take it mod 10. And I get my answer there, 49500. Now, just in case you don't believe me that these numbers are palindromes, let's see what they look like. We're going to get a long list, but you'll see these are all the palindromes. So what we did is we just checked to see if the left number was the same as the right number, and we didn't have to pay any attention to the middle number at all. So okay, that's an example. Another example of using filter, but this one with picking off digits. Now, If I had a 4-digit number and I wanted the palindrome, that would be a little trickier. Because how would you get the second digit of a 4-digit number? Well, we could do it. Suppose let's just, okay, randomly punch some numbers in. And I want to get the second digit. Well, I know that if I divide by 100, which is what I did last time, what happens? Well, now I get a 2-digit number. Right? So what could I do to this? If I want to get that 4, I want to grab that second number from the left. How could I do that? Well, what I could do is I could take my number and I could divide by 100 and then take the rightmost digit there, because we know how to take the rightmost digit, and I get 4. So in general, if I want this digit, I can always use this trick. What if I want this digit? How could I do that? Well, if I take 3, 4, 8, 5, and I take integer division, and by 10, I'm going to get the left 3 digits. So if I were to take that, that's going to give me the 8. So I can get this middle digit here. Okay, so now we can actually figure out what the sum is of all these 4-digit palindromes. What I could do is I could say, okay, I want x for x. And so I want 4-digit numbers now. So we're going to go from 1,000 to 10,000, because I want that to go all the way up to 999, but I only want to keep it if, okay, so what do I need? I want the middle 2 digits to be the same, because they're going to need to be the same if it's going to be a palindrome. So that's going to be x integer divide 100 mod 10 has to equal x integer divide 10 mod 10. But I also need the outside digits to be the same. But those are easier, because in order to get the left digit, I'm just going to take x divided by 1,000. And in order to get the right digit, I'm just going to take x mod 10. And I hit enter, and I get my answer. Now, just in case you don't believe me that this is actually producing the palindromes, this is going to be a really long list, but you'll see what I'm getting is all the palindromes. And I even get them in this nice order, because we're sort of taking all the 1s on the outside first, right? The middle numbers have to be the same, and then we're taking the 2s on the outside. The middles have to be on the same. So you can see we're actually getting all of the palindromes. And this is thanks to picking the right filter. And the filter here has 2 parts, but I don't need 2 different if statements because we have an and to connect them. So the only way I want to keep the number is if the first thing happens and the second thing happens. So the 2 inner digits have to be equal and the 2 outer digits have to be equal. Both those things have to happen. If they do, then I keep the number. So that's an example of using sort of a filter that has 2 different requirements, but like you saw, we just write if once. And we use and.